Good evening and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This evening we'll be looking at solving more complicated equations involving exponentials and Lund's natural logarithms. Here's the first one. Solve e to the x plus 8e to the minus x equals 6. Now, first of all, something that we mustn't do is think, oh, e, the inverse of that is ln, so we can just go ln. You can't do that. We are going to use the relationship that ln of x is the inverse of e to the x, but we can't do it yet. This is actually a quadratic equation. It may not look like it yet, but what we're going to do is manipulate it and it will end up forming a quadratic. The first thing I'm going to do is deal with the fact that this is e to the negative x here. So I'm going to rewrite that. E to the x is staying the same, but I'm going to write that as 8 over e to the power of x equals 6. What I'm now going to do is I'm going to multiply the whole equation through by e to the x. So I'm going to multiply both sides of this equation through by e to the power of x. And what we just need to think about is when we multiply e to the power of x by e to the power of x, what do we get? Well, when you multiply, you add the powers, you add the indices. So what we would get when we multiply through is we would get e to the power of 2x when we multiply e to the x by e to the x. When you multiply 8 over e to the x by e to the x, cancels out the dividing by e to the x, which just leaves you with plus 8, and that equals 6 e to the x, because we're multiplying the right hand side of the equation by e to the x as well. It's beginning to look more like a quadratic. You might not be able to see it yet, that's okay. We need to think of an alternative way of writing e to the power of 2x. And we need to use the relationship that when you've got two things being multiplied together in the index, you can write that as a bracket. So I can write this as e to the x squared, because those two numbers either side of the bracket you would multiply to get the 2x. Plus 8 equals 6 e to the x, and you think, okay, he's been saying all the way through this is a quadratic. What do quadratics have to equal before they can solve them? They have to equal 0, so I'm going to subtract 6 e to the x from both sides of the equation, which gives me e to the x squared minus 6 e to the x plus 8 equals 0. Now this is a quadratic. It's possible to factorise and solve from there, but a lot of people don't like what it looks like with the e to the x in it. So what we tend to do at this stage is to substitute a different variable, a different letter for e to the x. So I'm just going to say let y equal e to the x, and that transforms my equation into y squared minus 6y plus 8 equals 0. Generally people prefer to look at that for then going through to solve it. I chose y. You could choose any letter you like, just don't use x because it's part of the thing that you're substituting. So factorise and solve. Y minus 2, y minus 4 would be the two brackets, which means the two solutions for y are y equals 2 and y equals 4. We're not done, because we're not looking for y, we're looking for x. We're solving this original equation to find the value of x, so now we need to remember the fact that we substituted e to the x for y and replace y now with e to the x. So both of these cases y has been replaced by e to the x. I now have e to the x equals 2. Now is the point where I can say, okay, what's the opposite of e? It's ln. So if I apply ln to both sides of that equation, I get x equals ln 2. And if I get the same over here, you get x equals ln 4. Now if you were being flash here, you could say that because 4 is 2 squared, you could use the powers rule for lns and bring that 2 down the front. So you could also say here that x equals 2 ln 2. So they are your two solutions for x for this equation. Join me in the next part when we'll go through a different type of equation involving exponentials and logarithms.